Hello everyone, this is Sangeeta, Assistant Professor, EC Department, SNS College of Engineering. So today's discussion is about the analysis of the performance of parallel computing in Samsung Mobile. So today's topics covers the basics of or the overview of parallel computing with an example and the basics of mobile processor, and finally we are going to see about the processor Exynos 9611 which is used in Samsung Mobile. So let us move on to parallel computing. What is meant by parallel computing? The parallel computing is the execution of many operations at a single instance in a time at a particular time, or in the same time. For example, we have numerous applications in everyday life and often are the basis for the strategies developed for the computer. Let us think about supermarket checkout line. So in the supermarket, the main goal is to have customers quickly pay for their items, and they want to pay for their items they want to purchase. This can be done by employing multiple cashiers to process or check out or check customers one at a time. So in this case, the cashiers can become experienced in executing the checkout process and checkout customers faster. So another strategy is to employ many self-checkout stations and allow customers to execute the checkout process on their own. So this strategy requires fewer human resources, that is extra human resources from the supermarket, and can open more lanes to process customers. That is this is called parallel processing in supermarket. So this parallel processing requires more resources, human resources and more lanes. So the customers may not be able to check themselves out as efficiently as a trained cashier, but perhaps more customers can check out quickly due to increased parallelism resulting in short lines. So, next we will see on why should parallel computing, why should we learn parallel computing, what is the importance of parallel computing, why we implementing parallel computing in computers, laptops and smartphones. So, what are the reasons behind the parallel computing implemented in various devices? So, there are four reasons. The one is faster runtime, and the next one is cost saving. Next one is energy. So the parallel computing can reduce the time to solution, increase the energy efficiency in our application, and enable us to tackle larger problems on currently existing hardware. So this the excitement today about parallel computing is that it is no longer the sole domain of the largest computing systems. The technology is now present in everybody's desktop, laptop, and even handheld devices like mobile phones. This makes it possible for every software developer to create parallel software and their local systems, thereby greatly expanding the opportunity for new application. Let us see one by one. The first one is faster runtime with a more compute cores. Reduction of an application's runtime or speed up process is the primary goal of parallel computing. So this is usually the biggest impact. So the parallel computing can speed up intensive calculations, multimedia processing, and the operations on big data. So the next one is larger problem sizes with more compute nodes. So the by exposing parallelism in application, we can scale up our problem size into sizes that we are out of reach with a serious application. So this is because the amount of compute resources dictates what can be done, and exposing parallelism permits us to operate on large resources, presenting opportunities that could never be considered before. So the larger problem sizes are enabled by the larger amounts of main memory, disk storage, bandwidth over networks, and to disk and CPUs. So in an analogy with the supermarket, exposing parallelism is equivalent to employing more cashiers or opening more checkouts lanes to handle a large number of customers. So the next one is energy. So the energy efficiency by doing more with less. One of the new impact areas of parallel computing is energy efficiency. With the emergence of parallel resources in mobile devices, it can speed up applications, allowing the device to return to sleep mode sooner and allowing the use of slower but more parallel processes that consumes less power. So moving heavyweight multimedia application to run on the GPU can have even a more dramatic effect on energy efficiency while also resulting in vastly improved performance. So the net result of employing parallelism can reduce power consumption and extended battery life, which is a strong competitive advantage in the supermarket in the market. So the parallel computing can reduce cost. Actually, the cost is becoming a more visible concern for the software developer teams and software users and researchers. So as the sizes of application and systems grow, they must perform a cost benefit analysis and the resources available to inform their development. So these are the reasons behind why we are using parallel computing, why the software users implementing parallel computing in various devices. Next, we will see on the basics of the smartphone processor. uh, so let us see about what is a smartphone processor. So our smartphone processor is also known as chipset, that is a component that controls everything going in our smartphone and ensures it functions correctly. So we can compare it to the brain of the human body. So every action that we can perform on our smartphone goes straight to the processor like our brain. So these actions are then converted to visual changes on our screen, and all of this happens in a split second. So how does a smart phone processor works? So if we are opening a few pictures in our app, this action is registered by the processor and stored it into the memory of our devices. So in all the computers there are four cycles, that is a fetch cycle, decode cycle and execute cycle. In the fetch cycle, the data is fetched from the memory or from the devices, and it is decoded it into the machine languages, that is the understandable by the processor, the language understandable by the processor, and then it is executed. These are the three main stages of for an execution of for an execution. So the first stage is fetch, and the next stage is decode, and then last stage is execute. So in the first stage of the smartphone processor, fetch, that is that is our action is fetched and store it in the memory of our device. The action is then translated to ones and zeros, that is called machine language, which is understandable by the processor. It is called decode phase, that is the conversion of zeros and ones. The action the conversion of action into zeros and ones are called decode phase. The instruction are now saved in language of a smartphone understands. It's already for the execute phase. The processor transmits the ones and zeros, and we can see it all happen on the screen. So our pictures are opened. Finally, the executed instructions are saved in the register memory during the save phase. Afterwards, the process will start. So let us see about what determines the processor speed. So because why we are studying the speed means because of the speed we are implementing parallel computing. So the parallel computing needs more processor to execute the programs simultaneously. So the speed at which a processor processes a certain actions depends on a number of factors like the number of processor cores, The clock speed is another important aspect. The processor with a low clock speed and a smaller number of processor cores work more slowly than the processor with high clock speed and a large number of processor cores. So the clock speed determines how many instructions the processor can execute per second. This is called throughput. That is, the number of instructions per second is called throughput. So a processor, for example, a processor with a 1 GHz clock speed can process 1 billion instructions per second. The general rule is that higher clock speeds make for faster phones. So we can often see this with the more expensive smartphones. Their processor cores have higher clock speeds than those of more affordable devices. The number of processor cores also influences the speed of our smartphone. So next we will discuss about processor cores. So processor cores are also known as CPU, or also known as cores. So in every smartphones we have we can have more cores, that is dual cores, that is two cores, two processors, quad, hexa, octa. So whatever the speed, whatever we need the performance, we can increase the number of cores. So what do these cores do exactly? The processor cores distribute the work that comes in when we see our phone. So one core has a maximum number of instruction it can process within a certain amount of time. So if we want to perform a lot of actions on our smartphone, a queue of sorts will form. A queue will form. That is, if the queue gets too long, part of it will go to the next core. So in a parallel computing requires more number of cores, that is more number of processor, more than one processor it needs for parallel computing. So this ensures our smartphone will keep functioning smoothly. So the overall, the processor of our smartphone is the component that converts all our actions into visual changes on the screen. It can do the things to the number of cores and a certain clock speed. The number of cores ensures actions are always processed on time. The clock speed determines the amount of instruction that can be executed per second. So the higher the clock speed, the faster the smartphone. Next, we will move on to the Samsung's Exynos 9611 processor. So the Exynos 9611 processor brings intelligent performance for the next generation experiences, from artificial intelligent applications to pro grade pro grade camera that makes smarter enhancements to photographs. Built with a 64-bit core CPU and powerful GPU, the Exynos 9611 processor lets the user to do more of their favorite activities such as gaming. So next one is the main important features of Exynos 9611 is artificial intelligence. The machine learning is now vital for the next generation mobile devices. The Exynos 9611 processor is designed to offer artificial intelligence capabilities through a deep learning technology. Built with a digital signal processor and a neural network engine, the vision image processing unit of the Exynos 9611 can analyze the analog signals of images and videos and identify the objects and environment within the scene. So the technology enables the users to enjoy enriched photography experiences and do more with the intelligent assistant services. And the next one is the Exynos 9611 with 64-bit octa-core CPU enable seamless multitasking, that is parallel computing or multitasking, both are same, and faster app launching. While 4 Cortex A73 cores with a clock speed of up to 2.3 GHz handles performance intensive tasks. This course that runs up to 1.7 GHz takes lighter and always on tasks. With intelligent task scheduler, the Exynos 9611 delivers great balance of the performance and power efficiency for seamless mobile computing mobile computing. So in newest in all the mobiles, mobile phones have great computing power. Just take incredible games and video games that android phones are capable of running. But can we use the power for other tasks like high performance computing, vision algorithm, or efficient mobile data analysis app? So currently for parallel task, multi-threading concepts and asynchronous task is there in Android phone and other smartphones. So as far as about using multiple cores of the processor, one has to go to the hardware level, not just high level programming. So in this could be done in using OpenCL libraries in C++ using NDK also. So, um, so in the past decade, mobile phones have become a commonplace technology. In the same period, computer vision and machine learning have become a vital part of security analytics. So the high performance computing and parallelization methods have made it possible to quickly and accurately do intensive computer vision tasks like recognition and motion tracking, which have a greatly improved security in places like airports and government facilities. They have only been trial efforts to put such security onto mobile devices. Most face recognition method requires a still picture and would be too slow with a live video stream. However, the smartphones are becoming more and more powerful, and the components on them, such as the GPU, can be utilized to perform these tasks. So we are seeking to identify the more efficient way to utilize the GPU on a mobile phone for computer vision tasks. So in Samsung Exynos 9611, many different computer visions libraries have been implemented on Android devices because on their popularity and powerful hardware. So in Samsung Exynos 9611 implementing a parallel computing. So it uses OpenCV, an open source computer vision project is a robust multi-platform example of this libraries. However, it does not always utilize the entire mobile phone's hardware. So we can determine how important the GPU is in computer vision tasks, and also if there are more efficient methods to complete them. So because of parallel computing, all these applications are possible in a smartphones, that is face recognition methods and video stream are also possible in smartphones. So in Exynos 9611 implements the parallel computing, and so that the energy and times are saved, and various applications we are using by using the parallel computing. Thank you. ரெண்டு நிமிஷத்துக்கு என்ன வேஸ்ட்? ரைட் மோடில் தானே